Hello guys, welcome to another tutorial, and this one we're going to talk about how to transfer our rig to game engine. And so what we have here in the scene is two animations. One is a walking cycle and another one is this kicking animation. They're all captured data from Maximo. Okay, don't know why I'm showing those gizmos. Let's show none, show maybe polygons, controllers, and then joints. Okay, anyway, so we want to export our model into the game engine, including the animation. So a few things to be aware of. One is that you wanted to have just one root joint. Okay, another thing is your geometry should have simple history. In this case, I have many history actually, but they're all related to the rigging, and also for many of the inputs here, only the skin cluster and the Plinth Shape are able to transfer over. The others, like wire deformer, they don't really transfer. Okay, something to know about. Okay, another thing you want to always be sure that you're having it correctly is that all the joints are added as a joint that is banded with the skin. In our case, if you do recall, we don't really have the two eyeball joints added to the skin cluster, so let me go ahead and do that. It can be added to anything. It can have 0 weight. It just have to be in the list. Okay, so that's what we have to do. Okay, so again, what I did is grab the two joints and then the geometry, skin, add influence. Another thing I forget to do here is that, or I actually have trouble with, is name clashing. You can see I have the same name over here and the same name over here. Okay, now that's not very good. So what I need to do is change that naming. So this is going to be the red I01. This should be red I02, right? Make sure that there is no name clashing. Otherwise, you'll have trouble also importing. Okay. All right. So after that, we can then try to export our mesh and our animation. To start with, I can grab my joint and unparent it. We elaborately decoupled our bending joint, this guy, outside of our rigging controller system, so that way we can easily just get this guy out, right? And then our mesh group, which is also not inside of the structure of the rig group, so that way the rig group is separated completely from our skeletal mesh, right? The joint and the mesh. All right, so we go for File, Game Exporter, and inside of it, underneath the model section, default settings should be fine. Things need to be checked is the skinning and blend shapes. Okay, that should be checked down if you're doing with Unreal Engine. Here in the animation clips, you need to then specify the animations. We can go to the this export option here. I'm going to choose the export object set, and then we hit this guy to create a set while we're selecting those two things, and we can call this guy Sophia. Okay, and hit OK. All right, now you can see what this does is basically creating a new set, a selection set, and that set has those two things, right? So now, no matter what we're selecting, it's going to use those two things as the things to export. In the animation clips, we can then specify the animations. I have two animations, right? And the first animation is a walking cycle. It's going to go from frame 1 to frame 23, right? So let me add a new one, and 1 to 23. Another one is from 30 to 119, so I'm going to do that. Oops, 30 to 119. We can give them name. So the first one is a walking cycle, right? The second one is a kicking. All right, so two animations. You can play to preview those animations. It's going to automatically also change your time range to 0 to 23 on the time slider, which is pretty convenient. You can then switch to a different one and take a look. All right, And then in the settings here, make sure that you have the baked animation here so that your animation will be baked. Default setting will have it. The others should be irrelevant. And go to the path here, and I'm going to put it into a folder here. It can be anywhere, right? And just choose that. You can also give it a prefix. So I'm going to call this guy Sophia, right? Underscore. And when you're exporting it, it's going to save multiple clip files. You can choose just one, or you can choose multiple. Okay, I would like to separate those guys into multiple ones. Anyway, so now when those things are all set it up, what's going to happen is when you hit export, it's going to save two files. One is Sophia underscore walking, and then the one is Sophia underscore kicking. And we just hit export, and that's going to go through the process, bake your animation, and do whatever is needed to do to get those two things out, right? Our joint and our geometry. And let me hit OK. Now back here to Unreal, what we do here is just go import, and let me grab the kicking for now and open that. Okay, and the options will pop up. We should import the mesh and the skeletal mesh, and make sure that you also check on import morph target. It's not going to be in the default setting. It's also hidden, so you have to click here to open it and check on import morph target. Animation is something we needed. Use the exported time, right? And that should be everything. So go ahead and import all. Okay. Depending on how heavy your model is and how much blend shape you have, because I have quite a few, like I have 81 blend shapes, and you can see it's trying to go through every individual one. Okay. They're called morph target in Unreal Engine. All right, cool. When they're done, now you can see we have our models here. Okay. Now, if everything goes smoothly, you shouldn't got any warning. But if you do have any warning or errors, just read through those things and see what they say. Sometimes they're going to tell you, okay, two of the joints, like before, if we never rename our joint to make them not having the same name, we'll got an error in importing which says that you have the same name. If we never bend those two joints to the skin, it's gonna complain about those two joints doesn't have any vertex weighting at all. You may get those warnings. Anyway, if your rig is clean, you shouldn't get any warning. Okay. Anyway, so now we have imported quite a few things, right? This is the skeleton, okay, which is gonna be our joints. This is the skeletal mesh, which includes information of the joint, the skin, the morph target, and all sorts of stuff. This is the animation, and this one is the physics asset, which is basically the collision thing automatically generated for the for this mesh. Let me double click to open the skeletal mesh. Okay. Now instead of this mesh, we can see we do have all the joints. If you don't see those joints, you can go to characters, bones, and then you change that from none to all hierarchy. That should allow you to see the joints. You can also go to the skeleton and take a look at the joint hierarchy. You can see we have the root, and all the way to every joint we have. Okay, very clean and very accurate. One thing to be aware of is this red guy here. Okay, this red line indicates how much the root has offset from the origin. Okay, so if you don't have any joint on the root at the origin, it's going to consider that as the origin, as the root, and the root is offset from the origin that much. The red line indicates that. Okay, now that's going to be actually not an issue for anyone who just want to render your animation into Unreal. For anyone who just uses simple like animation in the gameplay, it should also be fun. It becomes not fun when you need to use root motion, which we'll talk about later. But for now, this is what I have. And we can check the animations here. And you can see our animation here. As you can see, also this red line indicated how much the first joint in your hierarchy is offset from the origin. Okay. All right. And you can also take a look at the physics asset and what's that. That's what that physics looks like. Okay. Basically, those are going to be the colliders that will collide. Anyway, so that's going to be how you import the animation into Unreal. Okay, same thing goes to Unity here. All you have to do is just go ahead and import a new asset and grab those two things and import. Okay. In Unity, when you import FBX, they will not give you options before you import them. You can change the options later. Although you do have to import the meshes. As far as I understand, you have to import both meshes for both animation. Okay, so they will all be here. I'm wondering why there's no checkbox to turn off the meshes over here, but yeah, that's what they have. But they don't really introduce any performance hit. Maybe just make your file a little bit bigger, I guess. Anyway, so what we can do here is use those two animations now. You can preview those animations by grabbing that animation, hit play. You can see the animation we have, right? The same thing goes for the walking cycle. Okay. In Unreal, though, you simply don't grab two things and import. Like what I mentioned earlier, we only imported one of them, right? If we want to get a new animation inside of here again, we just import that new one. In this case, the walking one. But this time, or any time that you just need the animation to be imported, you just don't import the mesh. Okay, over here. Not sure why Unity doesn't have that. One thing you could do is, I hear people doing this, is duplicate those two things and delete the redundant geometry imported. But in Unreal, you can check not to import that mesh. So that it's gonna ask you for a skeletal mesh that does already exist and only import animation asset. So I can go import all. You can see only one asset got imported. Feels a bit cleaner this way. But you can double click to open that. You can see now that's our walking cycle animation. Okay. Another thing to be aware of is that both engines support blend shapes. For Unreal Engine, for example, you can go to the mesh. You can see all the blend shapes. Right, we can even test them by dragging those sliders. So let's go to the eyebrow up. You can see what it does. Right, so all right, so that's going to be everything you need to do actually to get the animation in. Back here to Maya. Now, one thing I want to mention is that root motion thing and the root joint down there, and why that's needed in Unreal Engine, or when it's needed. Okay, one thing I want to do here is add that particular joint. So what I need to do is go. I have actually a selection set for our my controllers. That way I can just grab them all and just zero the translation and rotations to go back to the. Oops, that one doesn't have. No problem, just zero that out. Okay, go back to the binding post, right? And then I'm gonna create a joint and put it in the origin. Hit X, holding down X and click there. Now this joint has to not be moved away from the center and not be rotated. You can call this guy JT underscore root motion base. Okay. All right, and then if we don't really make this root motion joint move, then there's no meaning of doing this, right? If you wanted to be able to take advantage of this extra joint, this joint has to be moved with the geometry. So what you do is you grab the root joint here and that root motion base, you do a constraint and you do a point constraint, make sure that you have maintain offset, apply that, and then you grab this base and you do key in the bake simulation. So it's moved with the hierarchy, and then you grab the open the joint and delete that point constraint, and you parent your original root to the new base. Okay, that way you play the animation, you can see now that the root is moving with everything else, right? If that one doesn't move, again, there's no need. I don't think there's any benefit or merit of really doing that anyways. Okay. All right. Oh, one thing I want to do is also move that back to the origin. Okay. So probably when I was baking that, I shouldn't move it up first in the first frame. So let me drag it down to there. You know what? Let me just keep it there. I think because that's our capture data that is over there, so I guess it's a better position. Because our original bending pose should still be in the origin. Or let me do that here. So one thing you want to do is make sure that this guy is in the origin in the bending pose, right? So speaking of bending pose again, this joint has to be bended with your skin. It cannot be just something wandering around and not really bended with the skin. So let me grab this guy, holding down D and X, and just drag it over to the origin. Okay. So one thing I need to do, again, right, is grab this joint. Oops. This joint. Okay. And then the skin here, we do skin, bend skin. And we do, actually not skin bend skin, skin, added influence, and add influence. That way it's remember that this is the bending pose, this is the origin, right? And then we can go to the animation. One thing we could also do, depending on what do you need. Sometimes you wanted to actually also bake the rotation. Let's actually do that this time. I can also want to capture the rotation if that's a little bit better. So let me go grab the base. Let me go back to delete all the animation here. Okay. Move it back to the origin. Okay. So let's do it with everything. So I'm gonna grab that root and our new root. Do a this time maybe parent constraint. So that way it's capturing everything there. It's gonna be a little bit weird, but that one actually now remembers all the motions from this root. Okay, and then let me delete that parent constraint. Okay. Oh, actually, before we delete it, kind of need to bake the simulation, right? So if you want it to be more stable, you don't do orient constraint. That way, the root motion will just remember the movement, not the rotation. If you include the rotation, it may becomes a little bit unstable when you use root motion. But basically, this one has to have some animation again. That animation can come from the root. That's all I'm saying. And again, this root joint should be also banded with the skin, and then you eventually parent your root, your original root, to this new root. Okay. All right, let's see again the merit of this, right? So why do we even need this? Let's go ahead and grab this guy, and then the geometry here. We need to go ahead and do one more export selection. Actually, not export selection. One more game exporter. Okay, and then this time I'm gonna use just the selection here. That should be fine because that's the thing I'm selecting now, right? And let's call it Sophia with root. Okay, and export that. Now this time again, it's gonna go through the same process, but this time again, we have one more root that is at the origin. It's having some movement which is inherited from our original root joint. Okay, and again, it's banded with the skin. Even it doesn't have any weighting, it has to be banded with the skin, just to make that really clear. Now let me go create a new folder and call this with root maybe. And let me go ahead and import, but this time we have the with root. Let me grab the kicking and open that and import all. Okay, again, it's gonna go through all the morph target. So morph target again, it should be able to transfer over, although we don't have any morph target animation, but if you have just the morph target, it should be able to transfer over nicely with animation, if you do have animation. For now, we don't have any morph target animation, but again, it should be able to get transferred, no problem. So yeah, let's take a look at this new one. Now it appears to be not that much different, but you also see that this line changes here, right? This line now is going to be the distance from the origin to that. Okay. All right. So why is that helpful? Because then what you can do is you can go here in the search bar, in the asset detail, you can look for the setting root motion, and you can enable root motion. Okay. And what it does is basically transferring the motion of the root, not on the animation itself anymore, but on the actual thing that drives like the character. Okay, so instead of in situations like oftentimes when you're having like a game character, the movement of the object you're playing, like the character actor you're playing, will be the actual movement, and you're just based on that movement to play corresponding animation to fake that it's moving, right? Like the walking cycle is not really walking forward. It's just playing a walking cycle stays stationary, and you're moving a capsule component. Then that's the real thing that is moving, and the geometry just follows it. But in situations like a dash or this kind of like kicking, you kind of wanted the actual root motion, right? This guy's movement to drive the capsule, right? The other way around, so that you're matching with the animation properly. Okay, and you check down the enable root motion. That's going to make it work. And to make it work properly, you have to have a joint that is at the origin. Yeah, otherwise, it's not going to work properly. Anyway, so let's see if we can do this, right? We just enable the root motion here. Okay, and think all we have to do just to preview it, we can create a blueprint character, call this guy test char, and then inside of it we can then specify our mesh to be our Sophia with root kicking, and drag it down and rotate it 90 degrees to face to the arrow. Okay, now we can tell her to use the animation asset and just use our kicking animation, which is this one. We just checked on the root motion, right? That's what we did. Oops, then drag that, open the full blueprint, drag that over to the animation to play. That way this character will just constantly play in this animation. Okay, but this time it's checked as use root motion. So this one uses the root motion here. Right, the root motion is checked down. So let's take a look at that. If we drag this guy over here, okay, and we do like a select viewport as, or we simulate this guy. Oops, not doing that. I guess we have to set up a complicated system with actual animation blueprint to make it work. Yeah, so let's do this then. Just to show you what this is, I'm gonna grab this guy and right click, create a animation blueprint, this skeletal mesh. We can call this guy and BP root motion, just to show you what this is, because sometimes it's hard to explain, and double click to open that. I'm gonna use, let me also import the walking animation. Don't need mesh, right, for new animation or any new animation now. Drag that over. That's gonna be my animation to start with. Okay, and then I'm gonna create a montage from the kicking. Yeah, okay, Sophia kick. Okay, and then double click on this guy. I'm gonna give it a slot, and this is gonna be kicking slot, and then that's gonna be using the kicking slot. Save that. Okay, now back here to the animation blueprint, and drag out from there, create a slot, and that slot will be the kicking slot. Okay, so whenever I want to play that montage, is gonna be played. It's gonna be played inside of this slot. Okay, and then back here to the character. I'll make sure that I'm using that animation blueprint. So this will be here. That's gonna be here in here, and I'm gonna choose the animation BP if I can choose that, or I can select it over here. Okay, so now we're using that animation blueprint You can see it's doing this animation, which is the default animation that is playing in the animation. But we have a slot here, and whenever we want to play that that kicking animation montage, right? This one is gonna play it in this kicking slot will be here, which will override what's gonna go through. So temporarily playing that kicking animation on top of the walking animation and override it. So we can then set up some control to do that here in the testing character. Just to be really quick, space bar, and maybe we'll ask the mesh to play the montage right here, and then we can just choose that Sophia cake. Okay, right. Connect that to here. So when we hit the spacebar, it's gonna play the montage, which is Sophia cake. Again, Sophia cake will go play in this kicking slot, and that kicking slot in the animation blueprint is over here, so it's gonna play over here, which overrides what's going on here, and that's gonna be the final result. That's how it works. Now here in the root motion settings, of the blueprint, you can see it's using the root motion from the montage, right? So that should be everything. Just to be able to visualize it, we can add. We should be able just to, yeah, because then we have to control this character. So let me create a camera here, and then that camera should be the viewport in the default settings. I'm just gonna drag it higher and move it to the back to see it. Right, compile and save that. Now here back to the scene, I'm gonna delete this guy and drag in a new test character. Right, you can see we're behind her. Let's make her facing that way. Right, go this time we want to possess her, so go to the detail and go to the setting here. We can search for possess, clear 0, right? Save that. Hopefully that's not too much. Go ahead and play this with the selected viewport. Okay, you can see she's doing this. Now we hit space button. You can see what's happening here now is, whoa. What's happening here now is we're using that root motion, right, to actually drive the character's movement itself, right? So that root motion drives us. Okay, maybe that's driving too much. So that's why I was trying to not use the rotation, but only use the movement. So it's up to you to use that motion, right? So if you want to get just the movement backward and forward from that, and then when you're baking your animation, you should actually choose to only, and let me delete the animation here, right? Because we were incorporating the rotation and it goes a little bit crazy. If you want to just capture that linear movement forward and backwards, up and down, but not rotating, then what we can do is we can do a constraint, point constraint. Okay, and then we go to the keys and bake the simulation here, right? And this time then we just have the movements forward and backwards, right? And we can parent that to the root again, right? Oh, actually not to the root to that. Okay, this time again you can see it's not going to be rotating, it's just going up and down, backward and forward. Okay, now if we do this again with root, no rotation, and export. Okay, this time if we use this one, we'll get a whole different result, right? A whole different experience. Let's take a look at that. So yeah, it's kind of like flexible. It's up to you to how do you want to bake those animations into the root motion. So again, this time, if I go ahead and import that no rotation kicking, it's the same joint structure, so I should be able to check off the input mesh, and just with the root kicking, yeah, import out. Okay, so this one with root but no rotation, right? We can double click to open that, and this time if we check root, enable root motion, you can see it's locked there but not having rotation, right? Rotation is not changed here. Okay, so that's a different approach, and we can save this and take a look at that in the animation. Here what we can do is replace the Sophia kicks here. Instead of using this guy, go to the animation, we can use no rotation kicking. Oops, as the asset used over here, right? Okay. Now if we go ahead and play our game, hit space, you can see now we're using that root animation, right? But this time we're using just the translation, not the rotation, so it feels a little bit more stable. Now this is needed when you wanted to use the animator's animation to drive how the character moves. And that's when you need that. So if you never really need that, then I don't think you really need that root motion. But maybe there's other uses, but that's the primary usage. I think that's important to mention here. Although this is a little bit more like interdisciplinary, right? So it has to combine both knowledge in the game engine and the rigging part to understand how this works. I think that's some extended thing that you kind of need to know if you want to use that feature, right? Root motion. If I were to not choose the root motion, let's take a look at that. So which one is it? No kicking, right? No rotation. So this one is this time if I disable that enable root motion, save that, and play the game, hit space, you can see she's just doing that, but you are now moving forward, and she will blend back to where it is. Okay, so that's the result to not use root motion, which is not going to be proper for this particular animation that does really have to utilize that. Okay, so you can also, when we do like if we can show the collider here, and play that and hit show collision. To show the collision, this big sphere in the middle, the dark red one is our capsule. Now if we hit space button, you can see the capsule doesn't move forward, right? Only the character that is moving forward, or the skeletal mesh. Right? That's without root motion. And then with root motion, let me go check that out. Right. Go ahead and play and show that again. You can see our capsule actually moves with it. Okay. All right. Cool. So that's gonna be the difference. All right. So that's the root motion. It's required that you have a join at the very origin when you do this. Okay. All right. What else? Yeah. So another thing to be aware of is that in the rigging process, it could be like there could be a lot of steps, and you could make mistakes in the middle. And so I do encourage you, if you're a new or beginner who is doing rigging, always try your rig in every little step when you have achieved. Try your rig and bring it into the game engine and see if it works, right? For example, you finished the skin weighting, right? After you finish that skin weighting, put it into the game engine and see if everything works. When that is done, maybe when you finished the span rig, bring it to the game engine, right? See if it works, and then so on and so forth. So keep trying that. Because there could be problems in the middle, could be mistakes that you made in the middle that makes the rig incompatible with the game engine. If you don't find that soon enough, then everything after that, every work you did after that, which builds on that foundation, will then have to be rebuilt because you have to change the foundation. Okay. So just to reiterate, only the skin cluster and blend shape can be transferred over. So this one and the blend shapes. Anything other than that, or more complicated than that, or have more layer than that, will not be able to transfer over. For example, if you have this, let me show you. Control D and duplicate this model and unlock selected. This is a common practice in rigging. You grab your body here, and then this body, you create a blend shape, right? Go here. I don't even have to do that. I'm gonna delete that guy, and you just add a target, right? So we can call this guy a new blend shape. Okay. Now you right click on it and rebuild the target. So you got the actual model out of it. Okay, move it away. So this is the blend shape, but if you go ahead and use something to influence this guy, like a little joint, and you use that, another joint maybe. Okay, if you use this joint, right, to affect the skin. So there's a joint affecting this blend shape. This blend shape will permanently be on the model. This is called local rig, common practice again. As you can see, that maybe you can see it does influence your model. This will not be able to transfer over because this geometry is not moved as far as Unreal Engine or Unity concerned, because the thing that moves it in Maya is an extra layer of skin cluster, and that's not going to be able to transfer over, right? So this kind of like local rig does not work. Okay, one thing to be aware of. Okay, so I'm gonna delete that. And also again, one single root, no more than that, is separated clean root hierarchy, and a mesh is all you need. You don't need any curve or groups. Okay. So one thing you can make sure that you're getting the right thing is you go open the things you exported. Make sure that you use all files here and grab the one of the things here and open them. Don't save. Okay. So once you open them, you should see only a few things, only the joint, the mesh, and the blend shapes, and nothing more. If you do see more, then it's gonna be redundant things, those things like the curves, groups on top of the joint, they're all redundant. Okay, not meaning that they're not gonna work. They could work, but still they're gonna be redundant, and sometimes that reduces the performance of the game because there is extra nodes, and that doesn't really make sense. I have that bad experience with Unity before, when you import something with a bunch of curves and groups on top, and even some constraints or whatever in the system, right, instead of the joints, that drastically reduced the performance of the animation, which is almost unusable. Okay, so make sure that you check it and see if you have just those things. Anything more than that, you can spend some time and clean that up, unparent your joint, delete those extra groups or curves, right? Just keep the joint and the mesh, and do the same thing for other animations you export. Also, not all rigs are perfect for joint based. There are some rigs out there, like the free rigs, like this Norman rig, will not be able to transfer easily because first of all, the joints are separated. So if you look for the root, right, this is the root rig, right? It's all modular based, and also it has some different systems, but that's the root rig. You have the root joint, and notice that the root joint is just its own system. You have the span, you have the hips, right? The problem is, again, they're separated systems. The joint for the root is here, but the foot is over here. So those two things are not parented to each other. In a single hierarchy, you have multiple roots, right? That's the problem. So yeah, when things like this happens, you have the controller, the joints, and the controller, and that's actually not a controller. If you take a look at it, it's actually a joint. Okay, and take a look at the show joints. You can see it does have a joint shape associated to it. It just have one more. If I display shapes, you can see just have this one more curve shape, which makes it looks like a curve. I can delete that curve shape, the disable no shapes. You can see now that thing suddenly becomes a joint. Okay, it just draw it as a curve if you give it a curve shape. You can also see here it does have, including this one, it does have a joint orient attribute, right? It's a joint, not a controller. So yeah, structure like this, if things are decoupled things are like separated like this, it will be really difficult. So make sure that you pick a rig that is actually gonna work, right? So again, a simple separatable binding joint chain and geometry that is completely not entangled hierarchically or anything else that is to the motion or controller system. and also have a simpler history, so your model just have a simple blend shape and a skin cluster, because those are the things that are able to transfer over, others are not. All right, cool. So that's gonna be it for this video. I hope all the information works for you, or if you do have any other comments, I would like to also know. This is a little bit interdisciplinary, right? So maybe some of the developers would actually have different choices for root motion or whatever in the setup of the character, but I think that's mostly based on case by case, right? So probably not going to be able to find a global solution for every situation. I personally think you don't really need that root joint in most of the situations, but it doesn't hurt to have one anyways, right? It's not going to give you a lot of performance hit. Alright, cool. So that's gonna be it for this video. Thanks for watching. See you next time.